Hello guys, in this video we are going to discuss the solution of the problem count inversions. So let us look at the problem statement. The problem statement says given an array of integer ARR, find the inversion count in the array. Two elements ARRI and ARRJ form an inversion if ARRI is greater than ARRJ and I is less than j. Inversion count. For an array, inversion count indicates how far the array is from being sorted. If the array is already sorted, then the inversion count is 0. If an array is sorted in the reverse order, then the inversion count is the maximum. So for instance, if this is the array which is given to us, then the number of pairs which forms an inversion is 2, 1, 4, 1 and 4, 3, because of which the inversion count is 3, and that is what we are returning over here. So that's about the problem statement, folks. Now let us discuss the solution of this problem. So the general idea behind solving this problem is to perform merge sort operation. While performing merge sort, we have to perform the merge operation. And while performing the merge operation, we are going to count the number of inversions. And that will give us our answer. So that's the basic idea behind solving this problem, folks. Now let us do a quick recall on the merge sort operation. So within the merge sort operation, what we are interested is in the merge operation. So as we know, in the merge operation, we are given two sorted arrays. Those two sorted arrays are, let's say, left array and right array. So let us say the left array is 2 and 4 and right array is 1, 3 and 5. As you can see, the left and right array are sorted. With these two sorted arrays, the inversion count is the number of pairs x, y such that x belongs to left part of the array and y belongs to right part of the array, and x is greater than y, and we have to count such x and y pairs. In this case, those pairs are 2, 1, 4, 1 and 4, 2. So in total we have 3 such pairs, and we will be going to return 3 for this case. Now it turns out when we are performing the merge operation, the number of inversion count can be given directly by n1 minus I, where n1 is the length of the left array. So this is my left array, n1 is the length of that left array, and I is an iterating counter on the left array. And we will discuss more about how this will be the case, but for now let us proceed forward. So that's the brief idea about solving this problem, folks. Now let us take an example to understand it completely. So to solve this problem, let us take an example. So let us say this is the array which is given to us and we want to compute inversion count. So for this, what we are going to do is we are going to perform merge sort operation. So as we know, in the merge sort operation, first we divide the array into its fundamental unit. So let us do that. So after dividing the array into two parts, the two arrays look something like this. Now let us divide it further. So the division of array will look something like this. So these are the fundamental units which we have. So 2 is one fundamental unit, 4 is another, 1 is another fundamental unit, 3 and 5 are another fundamental unit. Now we are going to perform the merge operation. So let us perform the merge operation. So let us merge these two elements of the array. So if you merge this, the array will look something like this, 2, 4. Folks, as you can see, the array is already in sorted order, so we don't have to do anything over here. Similarly, if we merge this part of the array, again, since the array is already sorted, so we don't have to do anything. And this one is as it is. Now let us merge further. So again, we are going to merge these two arrays. So if you merge these two arrays, the array will look something like this. Folks, as you can see, the array was already sorted, because of which inversion count remains 0. And this 2, 4 remains as it is. Now, finally, we are merging these two arrays. Now, when we are merging these two arrays, we realize that the array is no longer sorted. And in order to merge these two arrays, what we are going to do is we are going to take a pointer over here and we are going to take another pointer over here. So the pair which we form over here is 2, 1. Now, as we can see, this pair 2, 1, as we are comparing these two elements, form an inversion pair. Since the array is not sorted, 2, 1 is not in sorted order, basically not in ascending order, because of which this forms an inversion count. Now, once we realize that 2, 1 forms an inversion count, we also know that 4, 1 will also form an inversion count. This 4 is coming from here. The reason why 4, 1 will form an inversion count is because this array is already sorted. So if 2 forms an inversion pair with the element 1, then we also know that 4 will also form an inversion pair with element 1. Because of which the inversion count over here will be given by inversion count so far plus n1 minus I. n1, folks, is the length of the array. So the length of the left array is 2. And what is I? Well, I is this part. So this is 0. So this is 2 minus 0, which simply means there are two pairs, which are these two pairs, which are going to form an inversion pair. Now, once we have operated on 2 and 1, so as we know, in the merge operation, 1 will come over here. So 1 is gone from this position, and my left and right pointer will remain at this position. So the left pointer will be at this position and the right pointer will be shifted by 1. So the right pointer comes over here. Now since 2, 3 is already in sorted order, because of which 2 will come at this position, in which case the left pointer will be moved to the next position. So the left pointer will come at this position. Now we are comparing 4, 3. Now as we can see, this is not in sorted order, because of which this forms an inversion pair. Now since this forms an inversion pair, so the inversion count will be updated by inversion count so far, which is equals to 2 and n1 minus I. So this becomes equals to 2 plus n1 is equals to 2 and I is at the first index, which is 1. So this becomes equals to 2 plus 1, which is equals to 3. And in this way the inversion count becomes equals to 3 and 3 will come at this position, 3 will be striked off and the right pointer will move to the next position. Now 4, 5 is already in sorted order, because of which 4 will come at this position and 5 will come in this position. And in this way, while performing the merge sort operation, we have also counted the inversion count, which turns out to be 3 for this case, and this is what we are going to return. So that's the discussion of solution, folks. Now let us discuss the pseudocode of this problem. So let us say we want to count the number of inversion pair and an array is given to us. So for this, what we are going to do is we are going to perform merge sort operation. And while performing the merge sort operation, we are going to count the number of inversion pairs. So for that, ARR is starting index and ending index. So length of array minus 1. Now let us look at the merge sort function. So for merge sort function, an array is given to us. Its starting index and its ending index is given to us. So as we know, in the merge sort operation, the first thing which we are going to do is we are going to divide the array. So for that, let's have answer equals to 0. And then let's check if start is less than end. If start is less than end, then let us compute mid. Mid will be equals to start plus end minus start divided by 2. And after computing the midpoint, we are going to perform the merge sort operation on the left part of the array and the right part of the array. So this will be equals to answer plus merge sort. So left part of the array, so ARR is starting point, and till mid position we are going to sort it, and then we are going to sort the right part of the array. So merge sort ARR mid plus 1 to end position. And finally, this left and right part we are going to merge it. So for that, answer plus equals to merge operation ARR starting position, mid position and end position. And towards the end, we are simply going to return answer. So that's the merge sort function, folks. Now let us look into the merge function. So for merge function, an array is given to us. Its starting index, its mid index and its ending index is given to us. So the first thing which we are going to do is we are going to compute n1, which is the size of the left array, which will be given by mid minus start plus 1. Then we are going to compute n2, which is equals to end minus mid. So this is essentially the size of left and right array. Then we are going to create a left and right array. So left array, so this is my left array, and similarly a right array. So this is the right array. Now let us populate the left and right array properly. So for that, let's have I equals to 0 and j is equals to starting position. Then while I is less than n1, all we have to do is left of I equals to ARR j, and then we are going to increase our I and j counters. So I plus equals to 1 and j plus equals to 1. And in this way, using this loop, we have populated our left array. Similarly, we are going to populate our right array. So let us do that. Again, I equals to 0 and j is equals to mid plus 1. Then, while I is less than n2, right of I is equals to arr j. And then we are going to increase our I by 1. Now that we have our left and right array with us, we are going to perform the merge operation. So for merge operation, I is equals to j equals to 0 and k is equals to the starting point of arr. And then we are going to iterate on I while I is less than n1 and j is less than n2. And simply we are going to check if left of I is less than or equals to right of j. So in this case, the array is already sorted, so the inversion count remains as it is. And all we have to do is arr k is equals to left of I. And then we are going to increase our I and k by 1. If the array is not already in sorted order, then this is an inversion pair, so we are going to update our inversion count as well. But before that, let us make the array sorted. So arr k is equals to right of j, and then let us increase our j by 1 and count the number of inversion pair. So the inversion count will be equals to inversion count plus n1 minus I, and let us increase our k by 1. Now, after doing so, it might be possible that there exists some element in the left part of the array. So we are going to simply copy those elements into the array. So arr k is equals to left of I, and let us increase our I and k by 1. So I plus equals to 1 and k plus equals to 1. Similarly, it might be possible that there exists element in the right part of the array. So j is less than n2. And all we have to do over here is arr k equals to right of j, k plus equals to 1 and j plus equals to 1. And towards the end, we just have to return the inversion count. And in this way, folks, we will be able to compute the inversion count and we will be able to return it. So that's the pseudocode, folks. Now let us see how we have implemented this in Python and C++. So first, let us look at the Python implementation. Inversion count, this is the main function which we want to implement. We have just return self.merge sort. And in the merge sort function, as you can see, starting and ending index is given to us. We are first dividing the array into two parts, and we are sorting the first part of the array and then the second part, and then we are performing the merge operation. And towards the end, we are returning our answer. And in the merge function, we have n1 and n2, which is the length of left and right subarray. Then we have left and right array and inversion count. Then we are populating our left and right arrays, and then we are performing the merge operation. While performing the merge operation, if this is an inversion pair, then in such case, inversion count will be updated by n1 minus I. Towards the end, we are returning inversion count. So that's the Python implementation, folks. Now let us submit our solution. So our Python solution got accepted. Now let us look at the C++ implementation. So the C++ implementation is also the same, folks. We are performing merge sort over here, and starting and ending index is being passed over here. In the merge sort function, we are dividing the array into two parts. We are sorting the first part, and then we are sorting the second part, and then we are performing the merge operation. Towards the end, we are returning answer. And in the merge function, we have n1, which is size of the left array, n2, which is size of the right array, and then we have left and right arrays with us. Inversion count equals to 0. We are populating left and right array properly. Then we are performing the merge operation. While performing the merge operation, if this is an inversion pair, then the inversion count will be increased by n1 minus I. Towards the end, we are returning inversion count. So that's the C++ implementation, folks. Now let us submit our solution. So our C++ implementation also got accepted. That is all from this video, folks. In case if you have any question or comment regarding this video, please feel free to use the comment section and I'll try to address them. Thank you.